In this video, we're going to take a look at current. So by the end of this video, you're going to be able to explain what current is and how it is measured in a circuit. So let's start with a definition of a current. Current is defined as the measure of the amount of electric charge that passes a point in an electrical circuit each second. Now, if we go back to our analogy of our little men within this different pipe here, then current is if we take this point in our circuit, it is how many of these blue guys, how many of these amps, or how much electric charge is passing that point each second. Now, I think there's a couple of things we need to mention about current before we move on. First of all, it's really important not to confuse current with electron flow. So, electron flow is the flow of electrons, whereas current is we're talking about the flow of electric charge, which includes all the charged particles. The other thing we need to keep in mind is that current can actually flow in two different ways. So the first is direct current, or DC, which it's known as is short form. And this is current that flows in only one direction. So in our picture, our current is only flowing in this direction. The other way that current can flow is called alternating current, or AC. And so this is going to flow back and forth at regular intervals called cycles. So our picture would look a bit different where we would have the current flowing this way for a little bit, and then it would cycle back and flow in the opposite direction, here for a little while. And then it cycles back and forth doing that. All right. So, how do we measure current? Well, current is measured in terms of units, a unit called amperes or amps for short. We always give it the symbol capital A. So, you might see 5A or 7A. And what that means is we have 5 amps or 7 amps. Now, in terms of measuring it, we use something called an ammeter. And so an ammeter in our circuit actually needs to be connected in series. And again, we haven't visited what these terms mean yet, but it basically means that it needs to be connected so that the flow of electrical current or electrical charge goes through the ammeter in one pathway. Okay. So this would be an example of an ammeter connected to our circuit in series in order to be able to measure the current within this particular circuit. Now, one other thing we do need to keep in mind is electron flow and conventional current are actually two different directions. And this can be quite confusing. So, if we take our battery, for example, we have a negative end and a positive end. We know that if we looked at electron flow, it's going to flow from the negative end all the way around our circuit back to the positive end. So, electron flow always goes from the negative end of the battery to the positive end of the battery. Conventional current, just to make it confusing for you, actually flows in the opposite direction. Okay, so it goes from the positive end of the battery to the negative end of the battery. And the reason for this is that current was discovered well before the electron. And so initial observations saw the electric current going from positive to negative. But then after they discovered the electron flow, they basically kept this convention, even though we know the electron flow goes in the other direction. So just be aware, electron flow goes in one direction, and current or conventional current is always in the opposite direction. That's it then for this video. Let's move on to our next task.